students, welcome to Sunil's tutorial. I'm Sunil Mirwani and today we'll be doing this chapter called as wave motions. Let's see this. Take down the sum please. A man stands between two parallel buildings. A man stands between two parallel buildings. A man stands between two parallel buildings and shouts. A man stands between two parallel buildings and shouts. He hears the first echo. He hears the first echo after 0.6 seconds and the second echo after 0.9 seconds. He hears the first echo after 0.6 seconds and the second echo after 0.9 seconds. If the distance between the buildings is 255 meters, find the velocity of sound in air. Find the velocity of sound in air. Find the velocity of sound in air. Right? So let us assume that he is at a distance of x from first building. Therefore, he is going to be at a distance of, let us assume that he is at a distance of x from the first building and y from the second building. So, let his distance from first building equal to x. Therefore, his distance from second building is going to be y. Right? Now the total distance between the two buildings is 255 meters. So I can say x plus y is 255 meters. Right? Now let us assume that v is the velocity of sound in air. Let us assume that v is the velocity of sound in air. Now if v is the velocity of sound in air, if I shout, the sound will have to go hit the building and come back. For me to hear an echo, sound will have to go hit the building and will have to come back. So what will be the distance travelled by the sound for echo? Hence, I can say that the distance travelled by sound for echo is 2x and 2y. Right, 2x on this side and here again it will have to go hit the building and come back. Right, so it will have to travel a distance of 2x and 2y. Now, we know that velocity is equal to distance upon time. Velocity is equal to distance upon time. Therefore, I can say that distance is equal to velocity into time. Right? Velocity is v, right, into time. For the first echo, the time is given to you as 0.6 seconds. Distance is 2x. In the first echo, the distance is 2x. In which case, therefore, I can say that 2x is this. Similarly, I can say 2y is v into 0.9. Right? Now, but they have given me that x plus y is 255 meters. Multiply equation by 2. If I multiply by 2, I'll get 2x plus 2y. 5 2s are 10, 5 2s are 10 and 1 11, 2 2s are 4 and 1 5 meters. 2x is 0.6v, 2y is 0.9v is 510 meters. So in that case I will get 1.5v is 510 meters. V is 510 upon 1.5. So when you divide this, you will get this answer as 340 meters per second. So the velocity of sound in air is going to be 340 meters per second. Next. Take down next one please. Calculate the velocity of sound in air. Calculate the velocity of sound in air calculate the velocity of sound in air at 40 degrees Celsius at 40 degrees Celsius at 40 degrees Celsius, given that at NTP the density of air is 1.29 kgs per meter cube. Height is 76 centimeters. Right? Height is 76 centimeters. Density of mercury is 13.6 into 10 raised to 3 kgs per meter cube, and the ratio of specific heat is 1.4. The ratio of specific heat is 1.4. Now, let us assume that V0 is velocity at 0 degrees Celsius, right? Now, if I apply Newton's law, if I apply Laplace's correction, I'll get V0 is gamma P upon rho, right? V0 is equal to gamma. Gamma is given to you as 1.4, right? P is given by the formula HdG. Pressure is HdG upon rho. Rho is given to you as 1.29. So in that case, you will get this as square root of 1.4 into H, 76 into 10 raised to minus 2 D, 13.6 into 10 raised to 3 G, 9.8. We know that gravitational acceleration is 9.8 meters per second square upon 1.29. This will give you the velocity of sound in air at 0 degrees. When you solve this, you will get this answer as 331 meters per second. 331.6 meters per second. You will get V0 is 331.6 meters per second. Now let us assume that V1 is the velocity at 40 degrees centigrade. Now remember, whenever you are doing temperature, you have to first thing convert temperature into Kelvin scale. So I have already converted 40 degrees. To convert it into Kelvin scale, you multiply by, you add 273. So that is going to be 313 degree Kelvin. T0 is 0 degrees centigrade plus 273. So 273 degree Kelvin. So you know T0, you know T1. Now we know that velocity is directly proportional to square root of temperature. Therefore I can say V1 upon V0 is equal to square root of T1 upon T0. Right? V1 we don't know. V0 we found out as 331.6 is square root of T1, 313, T0, 273. Solve this equation. Once you solve this, you will get the answer of V1 to be 355.1 meters per second. Right? Take down next one please. At what temperature will the velocity of sound in air be 1.5 times, at what temperature will the velocity of sound in air be 1.5 times its value at NTB? 1.5 times its value at NTB. Now let's assume that V0 is velocity of sound in air at 0 degrees Celsius, right? Now at 0 degrees Celsius, that means this will be 273 degree Kelvin. Temperature is going to be 273 degree Kelvin. I've just explained to you that velocity is directly proportional to square root of temperature. Therefore, I can say that they've also said that you want the velocity of sound to be 1.5 times its velocity at 0 degrees Celsius. At what temperature will the velocity of sound be 1.5 times its velocity at 0 degrees? Therefore, I can say V1 upon V0 is square root of T1 upon T0. All you have to do is now just substitute the values. You should be able to get the answer for this. The answer for this should be, when you solve this, you should get this answer as 341.25 degrees Celsius. Next, let's see the next one, guys. Yeah, you have the value of V1. V1 can be written as 1.5 V0. T1 on, no, T0 you have is, T0 is 273. So all you have to do is just substitute and you will get your answer, right? You will do that on your own, right? At the end of the lecture, you will do it on your own. Right, next. Take on next one, please. The wavelength of sound is 21 meters at 25 degrees Celsius. At 25 degrees Celsius. Find the wavelength of sound at 37 degrees Celsius. Find the wavelength of sound at 37 degrees Celsius. First convert this into Kelvin scale. How do I do that? This is 37 plus 273 degree Kelvin. This is going to be 283.10 degree Kelvin. Right? Now once you have this, I can say that as the temperature changes, velocity and wavelength of sound increases, but frequency remains unchanged. As temperature changes, frequency of sound remains unchanged. Right? Now we know that velocity V is equal to n lambda. Similarly, I can say V2 is equal to n lambda 2. Also, we know that velocity is directly proportional to square root of t. Therefore, I can say that V1 upon V2 is square root of T1 upon T2. V1 can be written as n times lambda 1. V2 can be written as n times lambda 2 is square root of T1 upon T2. Right? Out of which I know lambda 1, lambda 2 is the only unknown. You can substitute this later and get the answer. You should get this answer as, substitute, calculate, you will get this answer as 21.42 meters. Fine. Take down next one, please. At what temperature will the speed of sound in oxygen be the same as the speed of sound in carbon dioxide
in oxygen?
Speed of sound in oxygen be the same as the speed of sound in carbon dioxide at 0 degrees Celsius. Right? And they give you that the molecular weight of oxygen and carbon dioxide, the molecular weight of oxygen is 32 and carbon dioxide is 44. Specific heat ratio for oxygen is 1.4 and specific heat ratio for carbon dioxide is 1.36. Now, guys, let's first find out the velocity of sound in oxygen, because everything for oxygen is given to you. Let's first find out velocity of sound in oxygen. By Laplace's law, velocity of sound in oxygen should be equal to gamma times RT upon molecular weight, right? So in that case, I can say that gamma for oxygen is given to you as 1.4. R is gaseous constant. Temperature for oxygen is not given to you. Molecular weight of oxygen is given to you as 32. Right? Now let's find out the velocity of sound in carbon dioxide. Velocity of sound in carbon dioxide will be same. Gamma times RT upon M. So this is going to be gamma. Gamma is carbon dioxide 1.36 into R. Temperature 273 upon M. M is molecular weight of carbon dioxide 44. Right? They said that at what temperature will the velocity of sound in oxygen be the same as the velocity of sound in carbon dioxide? That means they've given me that V0 is equal to VCO2. Oxygen is equal to carbon dioxide. Therefore, I can say that square root of 1.4 RT upon 32 is square root of 1.36 into R into 273 upon 44. Square root gets cancelled, in which case I will have 1.4 RT upon 32 is 1.36 R into 273 upon 44. R and R gets cancelled. T is the only unknown. You can calculate the value of T. 1.36 into 273 into 32 into 1.4 into 44. So you will come to know the temperature at which the velocity will be equal. You should get the answer for this as 192.87 Kelvin. Right? This finishes this chapter. We'll stop this here for the day. Thank you very much.